Hello everybody. Today we're going to discuss chapter 5, Metal Oxide Semiconductor Field Effect Transistors, MOSFETs. Having studied the junction diode in chapter 3, which is the most basic two-terminal semiconductor device, we now turn our attention to three-terminal semiconductor devices. Three-terminal devices are far more useful than two-terminal ones because they can be used in multitude of applications ranging from signal amplification to digital logic and memory. The basic principle involved is the use of the voltage between two terminals to control the current flowing in the third terminal. In this way, a three-terminal device can be used to realize a controlled source. Now, there are two major types of three-terminal semiconductor devices. One of them is the BJTs, bipolar junction transistor, which we studied in the previous chapter, and the metal oxide semiconductor field effect transistor, MOSFET, which we are going to study in this chapter. Compared to BJTs, MOSFETs can be made quite small and their manufacturing process is relatively simple. Also, their operation requires comparatively little power. Let's begin analyzing MOSFETs. Now, MOSFETs have four terminals: body, drain, source, and gate. Usually, body is connected to a ground. There's an equation for VOV, which is the overdrive voltage. I'm not going to dig deeply in the theory, so I'll just give you the basic information. VOV is the overdrive voltage, and it's equal to VGS minus VT. VT here is not V thermal, it's a constant number provided in the question. VGS is equal to VG minus VS, the first letter minus the second letter. Another equation is the Kn prime, the process transconductance parameter, equal to mu n COX. That's for NMOS. For PMOS it will be Kp prime equal to mu P COX. COX is the oxide capacitance and it can be calculated using the equation epsilon naught, which is a constant number, divided by TOX provided for you. Again, constant number. Kn is equal to Kn prime multiplied by the width of the channel divided by the length of the channel. Okay. As BJTs, MOSFETs has three modes of operation: the cutoff, saturation, and the triode. In BJTs, we used to call it active. Here we have triode. Now, as NPN, as in BJTs, we have NPN and PNP. Here we have NMOS and PMOS, negative and positive. And there's another type called CMOS, complementary metal oxide semiconductor, and this is the design. Moving on, the three terminals of the NMOS and PMOS are the drain, source, and gate. Body is connected to the ground and it's not represented. Okay, so S is always with the arrow. The source is always with the arrow. So here we have voltage at the source, voltage at the drain, and voltage at the gate. The I flowing through the drain is ID, and the current flowing through IG is called IG, and it's with the direction of the arrow. What's the value of IG? IG is always equal to 0 ampere. It's always equal to what? 0 ampere. Reason being that this is an open circuit. Here it's an open circuit, so there's no connection between them, so current will not flow. IG is always 0. Now, if ID is flowing here, okay, and IG is equal to 0, then what's the current here? It's supposed to be IS, right? But IS is equal to ID, so why should we introduce a new variable? Let's just call it ID, okay? Because IG is 0. Same thing applies here. Here, because it's PMOS, The arrow is entering, here the arrow is leaving. So we have VD, VS, VG. Okay? The current flowing through D, the drain, is called ID. And the current flowing through S is also called ID because IG is equal to 0. IG is equal to 0 ampere. Okay. The voltage differences here, the voltage drop between this point and this point is called VDS. And the voltage drop between this point and this point is called VDG. And the voltage drop between this point and this point is called VGS. Now here, in PMOS, I'm going to keep the naming conventions the same. I will not swap the letters. So where's VDS as NMOS? It's here, VDS. And we have also here VDG. So VDG here will be like this, VDG. And VGS is like this. Okay? Now, all the voltage drops in NMOS, they have to be positive, greater than 0. And all the voltage drops in PMOS are less than 0. Okay? Now, we have 3 modes: off, saturation, and triode. How do you differentiate between them? Through the conditions. Through the conditions. For off, VGS has to be less than VT. And for saturation, VDS is greater than or equal to VOV. And in triode, it's less than or equal to. Notice that there's equal in both saturation and triode. This means that when they are equal, we are in the edge of saturation. Edge of saturation, VDS is equal to VOV. Now, if you are in cutoff, ID is equal to 0 ampere. And IG is by default 0. Hence, all the currents are 0. For saturation, ID is equal to half Kn prime W over L VOV squared. For triode, it's Kn prime W over L VOV minus half VDS multiplied by VDS. In edge of saturation, which current are we going to use, the saturation or the triode? Actually, it does not matter. If you use triode and we replace every VDS with VOV, you will end up with the saturation equation. So it's the same thing. But I recommend using the saturation equation directly because it will be simpler for you. It will save some time. The same equations apply for PMOS, but the only difference is that if here it's less than, then here it's greater than. The signs are swapped. Okay? And again, off, saturation, and triode. And when they are equal, it's edge of saturation, and you will use the current of saturation. Now, when the question says that VDS is very small compared to VGS, then we are in a different region. Okay? In this region, the ID is as follows, and this resistance, and this region only, we have a resistance called RDS. RDS is the resistance between D and S, between the drain and the source. Okay? Now, let's start solving some questions. The question says, consider a process technology for which L minimum, the length is 0.4 milli, TOX is 8 nanometer, UN 450 centimeter squared divided by V multiplied by S, and VT is 0.7. Find COX and prime. Let's begin. So, COX is equal to epsilon naught divided by TOX. It was given here. Okay? And epsilon naught, we said it's a constant, which is equal to 3.45 times 10 minus 11. This will be provided for you if you haven't memorized it. And TOX is 8 nano minus 9. This will give us 4.3 millifarad over meter square, which is the unit of COX. Now, the other requirement is Kn prime. Kn prime is equal to mu n multiplied by COX. Now, COX is ready, but what's mu n? It's 450. But focus on the centi. We have to convert it to meter. So 1 meter is 100 centimeter. 1 meter square is 10,000 centimeters square. Now we have 450 centimeters square divided by Vs. This will result in 45 times 10 minus 3 meters squared. Okay? So here 45 times 10 minus 3 multiplied by 4.3 milli. This will give us 194 microampere over V squared. Okay? Part B says for MOSFET, for a MOSFET with W over L equal to 8 micrometer divided by 0.8 micrometer, calculate the values of VOV, VGS, VDS minimum needed to operate the transistor in the saturation region with a DC current ID equal to 100 micro. So how do we find VOV? You can find VOV from ID, and we are in saturation, so we have to use this ID. And we are in NMOS. How did I know that it's NMOS? If you read the question carefully, it says mu n, meaning you are in NMOS. So we have to use ID of NMOS. Actually, it's the same as the PMOS, but instead of Kn, we're going to use Kp. Doesn't matter. So the equation is ID equal to half Kn prime W over L VOV squared. 100 micro, half Kn prime is, according to the question, 100. Kn prime is 194. 194 micro multiplied by W. W is 8 micro and L is 0.8 micro. So 8 micro divided by 0.8 micro, and VOV is unknown. This will give us two values because VOV is squared. VOV is 0.32 plus and minus 0.32 volt. Now we have two values, but we have to pick only one. Which value is the valid one? Actually, we said that in NMOS all the voltage drops are positive, so we have to pick the positive number and neglect the negative number. Okay? Pick the positive and neglect the negative. So this is our answer for VOV. After VOV, we need to calculate VGS. Now there's an equation that relates VOV with VGS. It's equal to VGS minus VT. Where did I get this equation from? Here. VOV equal to VGS minus VT. So VGS is equal to what? VOV plus VT. What is VOV? VOV is 0.32 plus VT, which is given, and it's equal to 0.7 volt. This is equal to 1.02 volt VGS. After VGS, we need to find VDS minimum. Now VDS minimum, why did he say minimum? Minimum means that we are in edge of saturation. Edge of saturation. Now, when VDS minimum is edge of saturation, we know that at edge of saturation, VDS is equal to VOV. VDS is equal to VOV, and VOV is equal to 0.32 volt. So we're done for the second part. The third part. For this device, find the values of VOV, VGS required to cause the device to operate as a 1000 ohm resistor for a very small VDS. And there's a resistance. So which equation are we going to use? Which mode? This mode, right? Because this is the only one that has resistance RDS and says small. VDS is small compared to VGS. Okay. So what's ID there? ID is equal to mu n COX W over L VOV VDS. Mu n COX W over L W over L VOV and VDS. But we're not looking for this, we're looking for the RDS. RDS is equal 1 over mu n COX W over L and VOV, right? Yes. So RDS is equal to what? RDS is equal to 1000. Here in the question, 1000. Okay? Mu n COX is equivalent to K n prime, and it's 194 micro. W over L is 8 micro divided by 0.8 micro, and VOV is unknown. This will give us 0.515. After finding VOV, we need to find VGS. VGS is found from the equation of VOV. So VOV is equal to VGS minus VT. So VGS is equal to VOV plus VT, 0.515 plus 1.22 volt. Okay. Next question. Consider an NMOS transistor fabricated in a 0.18 micrometer process with L length 0.18 micro, W width 2 micrometer. COX is this, mu n is this, VTN is 0.5. We need to find VGS and VDS. That results in the MOSFET operating in edge of saturation with ID equal to. So we are in edge of saturation. Okay. ID is equal to what? Half Kn prime. We said in edge of saturation we're going to use the current of the saturation. So ID is equal to what? 100 micro equal to half Kn prime. We need to compute it. It's mu n COX. Mu n is 450 centimeter square divided by Vs, which is equal to 45 times 10 minus 3 meters squared over Vs. This is the same number as the previous example. So what's our COX? COX is 8.6 small f capital F divided over micrometer square. The usual or the normal unit is farad over meter square. So we need to remove the F, which is the femto, and the micro. Femto is equivalent to 10 times minus 15 times 10 minus 15 divided by 1 times 10 minus 12. Why minus 12? Because here we have a micro and it's squared. Minus 6 squared is 12. Because it's power. That's why we multiplied. So this will give us 8.6 times 10 minus 3 farad over meter square. Now we plug in numbers. So here it will be 45 times 10 minus 3 multiplied by 8.6 times 10 minus 3, giving us 387 microampere over V squared. Plugging this number here, 387 micro multiplied by W, which is 2 micro, divided by 0.18 micro. VOV is unknown. This will give us VOV equal to 0.22 volt and minus 0.22 volt. Okay, which number should we pick? Because we are in NMOS, we have to pick the positive and neglect the negative. Okay, after finding VOV, we need to find VGS and VDS. So VOV is equal to VGS minus VT. VGS is equal to VOV plus VT, which is equal to 0.22 plus 0.5, yes, equal to 0.72 volt. Okay, after finding VGS, we need to find VDS, and because we are in edge of saturation, VDS is equal to VOV, which is equal to 0.22 volt. Okay, part B. If VGS is kept constant, find VDS that results in ID equal to 50 microampere. So we need to find VDS when ID is 50 micro. ID is 50 microampere and VGS is kept constant, meaning it's the same as the previous part. So VGS is kept constant, hence it's 0.72 volt. Okay? Now, which region are we in? We need to think a little bit. Imagine this is the axis and this line is the threshold edge of saturation. Okay? And this is the zero axis. We have triode, then we have the saturation. Okay? This is the axis of ID. When we were in edge of saturation, what was ID? It was 100 microampere. So here it's 100 microampere. Now where are we? We are in 50 micro. So which region are we in? We are in the triode region. So we are in triode. Now we need to find VDS. How are we going to find VDS? From the equation of the current. So what is ID? ID is equal to, in triode, ID is equal to Kn prime W over L VOV minus half VDS multiplied by VDS. So ID is equal to Kn prime W over L VOV minus half VDS multiplied by VDS. ID is 50 micro, Kn prime is 387 micro, W over L is 2 micro divided by 0.18 micro. VOV is 0.22 minus half VDS multiplied by VDS. VOV, how did I know it's 0.22? Because Kn prime I took it from here, and VOV is the same because here we're having VOV is equal to VGS minus VT. VGS is the same, 0.72, and VT is 0.5, which will result in 0.22. So if you solve this equation, first you need to expand. You will get here 11.6 milli to 0.22 minus half VDS multiplied by VDS. 11.6 milli equal to 0.22 VDS minus half VDS squared. So here half VDS squared minus 0.22 VDS plus 11.6 milli. Solving this using quadratic equation using the calculator, you will get VDS equal to okay, 0.06 and 0.38 volt. Now we are in NMOS, so we have to pick the positive number, but both of them are positive. So what are we going to do? We need to check, are we really in triode mode in both of those numbers? Let's check. What is the check for the triode in NMOS? It's VDS less than or equal to VOV. Let's check. So is VDS less than or equal to VOV? VDS is 0.06 and it's less than or equal to 0.22. Is that correct? Because VOV is 0.22, right? VOV is 0.22. So is this correct? Yes, it is. Therefore, triode. Now, is 0.38 less than or equal to 0.22? No, it's not a triode. Okay, so 0.06 is our number. And the question asked us to find VDS. So VDS is 0.06. Okay, we're done for this question. Now, let's start analyzing MOSFETs. It says design the circuit in the following figure, which is this. Determine the values of RD and RS so that the transistor operates in ID equal to 0.4 milli. VD is this, and NVT, mu NCOX, length and the width. Okay. So the first thing that you have to do is decide the type of the MOSFET. So this is NMOS, and then we have to label. So this is VD, this is VS, ID, and IG is 0. And this is VG, okay? Then we have to label VD, VS, VG, ID, and RD with RS. VG is known, ID is known, VD is known, and we have to calculate the rest. Now, let's write down the equation of ID. But ID depends on the mode of operation. Which mode are we in? We need to assume. So as BGTs, we need to assume saturation this time. Okay? In MOSFETs, the priority is for saturation, because most of the time it will be saturation. Okay? So ID for saturation is half Kn prime W over L VOV squared. ID is equal to 0.4 milli. Half Kn prime is mu NCOX, and it's equal to 100 micro. W is 32 micro divided by 1 micro. VOV squared. So what is VOV now? VOV equal to 0.5 and minus 0.5. Which number are we going to pick? I'm going to take the positive number, because we are in NMOS. We need to neglect the negative number. Now after finding VOV, we can open it. VOV is equal to VG S minus VT, which is similar to VG minus VS minus VT, which is equal to VG is 0, S is unknown, VT is 0.7, and VOV is 0.5. So VS is equal to minus 1.2 volt. Okay. Now after finding VS, let's find RS using Ohm's law. RS is equal to VS minus 0 over ID. VS is minus 1.2 divided by what? Oh, sorry, it's minus 1.2, not minus 0, minus 2.5 divided by ID, which is 0.4 milliampere. This will give us RS equal to 3.25 kilo ohm. Okay. After finding RS, let's find RD. RD is also Ohm's law, which is 2.5 minus VD over ID. So it's 2.5 minus VD, which is from the question 0.5, divided by ID, which is equal to 0.4 milli. This will result in 5 kilo ohm. Okay. Next. Now all of this is based on an assumption called which is assumed saturation. So we need now to check, is it really saturation? And the check of the saturation in NMOS is VDS greater than or equal to VOV. VDS is greater than or equal to VOV. VD minus VS greater than VG minus VS minus VT. S and S, they cancel each other out. So we are left with VD, which is equal to 0.5, right? Yes. And VG is 0, because it's grounded from the circuit. And T is, I think, 0.7. Yes. So is 0.5 greater than minus 0.7? Yes, therefore saturation. Okay. Next question. Design the circuit I deleted in this figure to establish, or that figure number, to establish a drain voltage of 0.1. What is the effective resistance between drain and source? Hence RDS. To operate, VTN is this and KN is this. So first thing is we need to label NMOS, and then first type, and then label VD with VS and VG, ID, and IG is 0 ampere. Okay, so we need to find RDS. What's the equation of RDS? RDS is equal to 1 over UN COX W over L VOV, which is equal to UN COX is with W over L is 1 milli, and we need to find VOV. Now VOV is VG minus VS minus VT. VG is 5, S is 0, and T is 1. So the answer is 4 volt. Okay, so 4, and this will give us 250 ohm. Great. Now there's another way to find RDS. The other way is, what's RDS? It's V over I, Ohm's law, V over I. But which V? VDS over ID, because we only have ID. What is VDS? It's VD minus VS over ID. We do not have ID, so we can calculate it through the equation. VD is 5 and S is 0, missing ID. ID is equal to in this region it's mu and COX W over L VOV VDS. Let's write it down. Okay, it's mu n COX W over L VOV multiplied by VDS. So mu n COX W over L is 1 milli according to the question. Yes, 1 milli. VOV we just computed, which is 4, and VDS is 5 minus 0, which is 5. So this will result in 20 milliampere, and 5 over 20 milli is 250 ohm. Same answer. Okay, sorry, VD, is it 5? No, VD is 0.1 actually, so I made a mistake. VD is 0.1 here, 0.1, so here it's 0.1, hence this is 0.4 milli. 0.1 over 0.4 milli is 250. Okay, next, analyze the circuit shown. Let's cancel this. Okay, now it says analyze the circuit shown to determine the voltages at all nodes and currents through all branches. Let VTN equal to 1, Kn prime W over L equal to 1 milli ampere over B squared. Neglect the channel modification effect. We're not going to discuss in details what are those things. Let's just ignore them. Okay, I just want to discuss the basic things. Now we need to find all voltages and currents. So this is NMOS. Okay, this is VS, VD, ID, and this is VG. Now, how can we find VG? VG is simple. We need to do Thevenin here. Actually, not Thevenin, voltage division will do. There's no need to find R Thevenin. I will tell you why. Now, let's do voltage division. 10 volt, 10 mega, and 10 mega. Okay, V Thevenin, let's call it. So V Thevenin is 10 multiplied by 10 mega plus 10 mega, which is equal to 5 volt. R Thevenin is 10 mega parallel with 10 mega. So R Thevenin is equal to 10 mega parallel with 10 mega equal to 5 mega ohm. Let's redraw the circuit. So now we have a voltage source 5 volt with 5 mega ohm. Okay, and the rest is the same, 6 kilo ohm. We have the arrow here, and here we have also 6 kilo ohm, and then we have a 10 volt. Okay, now what is the current across IG? IG is equal to 0 ampere. So is there a need for the resistance? No, it's useless. So if this is 5 volt, then this is 5 volt. Hence VG is equal to 5 volt. That's why I'm telling you there's no need to calculate R Thevenin. Okay, there's no need to calculate R Thevenin. Only V Thevenin is enough. Okay, after finding VG, now what do we need to find? We need to analyze. We need to find everything. So we need to find VD, VS, VG we just found, and ID. So what are we going to do? First, let's assume saturation. ID is equal to what? Half Kn prime W over L VOV squared. ID is unknown, half. It's half 1 milli. It's half 1 milli W over L. W over L, which is 1 milli, Kn prime W over L is entire thing 1 milli, and we have VOV also. What is VOV? Let's check it out. VOV is VG minus VS minus VT. VG is what? 5. VS is unknown, and VD is also unknown. So let's keep it VS minus VT. VT is what? VT is 1 from the question. 1. So this is 4 minus VS. Okay? So here 4 minus VS squared and ID. So we now have one equation and two unknowns. We need a relationship between ID and VS, which is Ohm's law. ID is equal to VS minus 0 over 6K. So VS is equal to 6K ID. Here we can replace VS with 6K ID squared. Okay. Now 4 minus 6K ID squared is equal to, when you expand, it will be 16 minus 48K ID plus 36 mega ID squared. Why did it become mega? Because kilo multiplied by kilo is mega. Okay, so after you multiply, here it will be 8 milli minus 24 ID plus 18 kilo ID squared. Rearranging the equation will result in 18K ID squared minus 25 ID plus 8 milli equal to 0. Now if you are wondering why is it 25, it's because minus 24 minus 1. Okay. Next, using the calculator, if you solve it, you will get as a quadratic equation 0.89 milliampere and 0.5 milliampere. Now here we have two answers, but we have to choose one. Now if it was a voltage drop, then we can choose one through the polarities. If it's a positive and it's NMOS, then we are going to pick it and we're going to neglect the negative. However, here, as we are in NMOS and it's an ID, we cannot check the polarities. Plus ID cannot be minus. So which one should we pick? We have to convert to voltages and then do the checks, whether it's triode or saturation. Now, finding VD from ID, that's done through Ohm's law. Okay, that's ID. So it will be 10 minus VD over 6K. ID is equal to 10 minus VD over 6K. Hence VD will be equal to 10 minus 6K multiplied by 0.89 milli, which will result in 4.66 volt. Finding VD here, it will be equal to 10 minus VD over 6K. So VD will be equal to 10 minus 6K multiplied by 0.5 milli, and this will result in 7 volt. Okay, after finding VD, let's find VS, or let's stick with VD for now. Now, what's the check? We said that we have assumed saturation, therefore we need to check for saturation. Now the check for saturation in NMOS is VDS is greater than or equal to VOV. VDS is greater than or equal to VOV. VDS is greater than or equal to VOV. VD minus VS greater than VG minus VS minus VT. What will happen to S? They will cancel each other out. VD is 4.66 greater than VG. VG is what? VG is 5 volt. Minus VT, which is, I guess, 1. Let's check. VT, yes, it's 1. So 5 minus 1 is 4. Is 4.66 greater than or equal to 4? Yes, it is. Therefore, saturation. Should we check now for the other possibility? Yes, we have to. Because what if it appears to be saturation? We still haven't done anything. We didn't cancel any number. So let's do it again. VDS is greater than or equal to VOV. VD minus VS greater than or equal to VG. VS minus VT. Okay. So S and S, they cancel each other out. VD is 7 greater than or equal to 5 minus 1. So S7 greater than or equal to 4. Yes, therefore saturation. See, in this case, we haven't cancelled any number because both of them appear to be saturation. Now, if it's in saturation, this means by default, it's not in triode because saturation VDS is greater than or equal to VOV. And in triode, VDS is less than or equal to VOV. So what should we do now? Now we should check for the cutoff, the region that we haven't checked on. So what's the check for cutoff? It's VGS less than VT. VGS less than VT. VGS less than VT. VGS less than VT. So is VG minus VS less than VT? In order to solve this check, we need the VS first. So let's do it. Let's find VS. How do we find VS? Through Ohm's law again. It will be ID equal to VS minus 0 over 6K. So VS is equal, ID is equal to VS minus 0 over 6K. So VS is equal to 6K multiplied by 0.89 milli, which will equal to 5.34 volt. Doing the same thing here, Vs minus 0 over 6k, Vs is equal to 6k multiplied by ID, which is 0.5 milli, correct? Yes, milli 3 volt. Okay, now let's complete the cutoff check. Vg is 5 minus 5.34, is it less than Vt, which is 1, minus 0.34, is it less than 1? Yes, it is less than 1, therefore cut off. So is this our number? No, it's not our number because it appears to be cut off. It's not it's cut off, it's therefore not saturation. Okay, we want it to be saturation. So if it's saturation, it should not be cut off. Okay, let's do the same check again. VGS less than VT, VG minus VS less than VT, is 5 minus VS. What's Vs? 3 less than 1. Is 2 less than 1? No, 2 is not less than 1, therefore it's not cut off. If it's not cut off, therefore it's our number. Hence, the question asked us to find all the unknowns, which are VD, VG, VS, ID. ID is 0.5 milliampere. Vs is equal to 3 volt, Vg is 5, Vd is 7 here. Vd is 7, Vs is 3, and Vg is 5. It's a constant number. It doesn't depend on saturation or cutoff. Okay, we're done with this question. Next. So design the circuit so that the transistor operates in saturation with ID equal to 0.5 milliampere and Vd is, let the PMOS transistor have VTP Kp prime W over L. What is the largest value of RD while maintaining saturation region? What does this mean? Maintaining saturation region means edge of saturation. Okay, so now which region are we in? We are in edge of saturation. There's no need for assumption nor for check at the end. Now at edge of saturation we know that VDS is equal to VOV, correct? Yes, so if we expand it to be VD minus VS equal to VG minus VS minus VT. Here this is S, this is D, and this is VG. VG is unknown because RG1 and RG2 are unknowns. We have to find them out, and also RD. Okay? So, how can we find RD? RD is simple, but that's not at the edge of saturation. We can say that ID is equal to VD minus 0 over RD. ID is known, VD is known. Let's calculate it. It's 3 minus 0 over 1 milli, 0.5 milli. So this will result in 6 kilo ohm. Now this is not the maximum. This is not the maximum. That's not at the edge of saturation. Okay? Okay, so we need to find it at the edge of saturation. Here Vs and Vs, they cancel each other out. In order to solve for RD max, VD minus 0 over RD, correct? We need to find RD max, hence VD has to be maximum. It has to be maximum. Okay, so we will find VD from here. VD is equal to VG minus VT. What is VG? VG is unknown. What's VT? VT is minus 1. So we still need to find VG. How can we find VG? We can get it from the equation of the current. ID is equal to half mu P, because this is PMOS, mu P Kn prime W over L VOV squared. Now half Kp prime W over L is 1 milli, and VOV squared is unknown. This is 0.5 milli. This will give us 2 VOVs equal to VOV equal to 1 volt and minus 1 volt. Which number should we pick, the positive number or the negative number? We are in PMOS, hence we need the negative number. We will cancel the positive number. So VOV is minus 1. If VOV is minus 1, which is VG minus VS minus VT, minus 1. VG is unknown, VS is 5 here, and T is minus 1. So VG is equal to 3 volt. Plugging 3 here, we will get 4 volt. So it's 4 divided by 0.5 milli, which is equal to 8 kilo ohm. This is the largest number, okay? This is the largest number. It's even bigger than the 6K here. Sorry, this is even bigger than the 6K here. Okay? Now, we need to find RG1 and RG2. How can we find it? Now, we know that IG here, it's equal to 0, right? So this part of the circuit is independent from this part of the circuit. No relationship in terms of current. So we can split them apart. So here, 5 volt RG1 is 2 mega ohm. Okay, yes, RG1 we know it, right? No, it wasn't given to us. I think we have to assume it. Okay. RG2. This is VG. Now this is the rest of the circuit, but it's independent due to 0 current. Anyhow, so here in order to find RG2 or RG1, we need one of the resistors. Let's assume the question said RG1 is equal to 2 mega ohm. Okay, now we need to find RG2. How do we find it? We already know that VG is 3 volt. So what can we do? We can do actually voltage division. So we can say that 3 is equal to the total voltage multiplied by RG2 divided by RG2 plus RG1, which is 2 mega. If you do this using the calculator, you will get RG2 is equal to 3 mega ohm. Okay, then from this question, let's go to the next. Now it says find the value of R that results in the PMOS transistor operating with an overdrive voltage 0.6, VTP is minus 0.4, process transconductance parameter is 0.1 milli, and W over L is given. We need to find R. Whenever the question says find R, you have to think Ohm's law directly. This is PMOS. This is VG, this is VS, this is VD, and this is ID. Now ID is equal to 1.8 minus VS over R. What is R? R is equal to 1.8 minus VS over ID. Okay? Now, we do not have neither ID nor VS. Let's start calculating. Now, in order to start finding ID or VS, we need to assume. So we will assume active. Sorry, assume saturation. I was thinking of chapter 4. Uration. Okay? And saturation ID is equal to half mu P PCOX W over L VOV squared. ID is unknown. Half Kp prime is 0.1 milli. W over L is 10 micro over 0.18 micro multiplied by VOV. What is VOV? VOV is VG minus VS minus VT, but it's given already in the question directly. VOV Absolute value of VOV is 0.6 volt. Now there's a trick here. What does it mean that there's an absolute value on VOV? This means that VOV itself can be either minus 0.6 or 0.6, and with the absolute value it will become a positive 0.6. Now you have to pick which number are you going to take, minus or the positive number, because it depends on the type of the MOSFET. Because we are in PMOS, then we have to pick the minus 0.6. So make sure you don't fall in this trick, minus 0.6. Now you might say that here it does not matter because of the square. Well, yes, you're right, here it doesn't matter, but it matters somewhere else here. Okay, there's no square here. Anyhow, so if you compute this, you will get a 1 milliampere. 1 milliampere. This is ID. Now, here we said VOV is minus 0.6, VG is 0, ground, S is unknown, T is minus 0.4. So VS is equal to 1 volt. After finding VS, now we can compute R. We can say that R again is 1.8 minus VS over ID. So it's 1.8 minus 1 over 1 milli. So it will be 800 ohm. Then we need to check. This is the last step. Check. We need to check for saturation. VDS is greater than or equal to VOV. For PMOS, it's greater than. For PMOS, it's greater than. No, actually, it's less than. Okay. VDS has to be less than VOV. VDS has to be less than VOV. VDS should be less than or equal to VOV. So is VDS, VD minus VS less than or equal to minus 0.6? VD is 0 and S is 1. Is minus 1 less than minus 0.6? Yes, it is. Therefore, saturation. Okay. Next, we need to find here ID and VD. Given that VT is 1 and Kn prime W over L is 1 milli. So we start by assuming saturation. Assume saturation. Okay. After we assume saturation, first let's say that this is NMOS. This is VD, VS, and VG. ID and ID. Okay. After assuming saturation, we will say that ID is equal to half mu NCOX W over L VOV squared. Half Kn prime W over L is 1 milli. VOV squared is, we need to compute it. VOV is equal to VG minus VS minus VT. VG is 5, S is 0, T is 1, which is equal to 4 volt. 4 squared, this will result in 8 milliampere. After finding ID, let's find VD. So it's Ohm's law. ID equal to 5 minus VD over 24.8 K. So ID is equal to 5 minus VD over 24.8 K. 5 minus, and here it's 8 milli. VD over 24.8 K will result in minus 193.4 volt. Now we need to check. Is it really saturation? And we are in NMOS, so it will be VDS less than or equal to VOV. Okay, is VD minus VS less than or equal to VOV, which is 4. Here VOV is 4. VD is minus 193.4. VS is 0, I guess. Yes, less than or equal to 4, and minus 193.4 is less than or equal to 4. True? It's true. I think our check is wrong. 4 for NMOS, VDS has to be greater than VOV. VDS has to be greater than VOV. I always make mistakes with this. Greater than, greater than, greater than, greater than. Is this correct? No, it's not. Therefore, not saturation. Therefore, triode. Therefore, triode. Okay? Now, let's solve it again with triode. In triode, ID is equal to mu n COX W over L VOV minus half VDS multiplied by VDS. Now, ID is unknown. Mu and COX is 1 milli. VOV is 4 minus half VDS multiplied by VDS. So now we have two unknowns and one equation. What is VDS? VDS is VD minus VS. VD is unknown, but VS is 0, so it will be equal to VD. Now we need a relationship between VD and 1 milli 4 minus half VD multiplied by VD. We need a relationship between VD and ID, and we can get this from Ohm's law. It will be ID equal to 5 minus VD over 24.8K. 5 minus VD over 24.8K. So VD is equal to 5 minus 24.8K multiplied by ID. Now, which is simpler? To replace ID with 5 minus VD over 24.8K, or replace every VD with this entire thing? No, I think this is simpler, right? Because here it's lengthy first of all, and then you have to multiply them together, so it will be complicated in terms of math. Okay, so ID will become 5 minus VD over 24.8K equal to 1 milli for VD minus half VD squared. Simplifying this, it will be 24.8 milli and K, they cancel each other out. Then this will become 5 minus VD 99.2 VD minus 12.4 VD squared. 12.4 VD squared minus 100.2 VD minus 5 is equal to 0. Sorry, it's minus 5, right? No, it's plus 5. I'm taking everything to the other side. Okay, so now using the calculator solving quadratic equation, you will get VD equal to 8.03 and VD is equal to 0.05 volt. We need to figure out which number is the correct number. We will do this through the checks. So first we will check for the triode. Triode is VDS less than or equal to VOV. So VDS has to be less than or equal to VOV. VDS less than or equal to VOV. VD minus VS less than or equal to VOV is 4, I guess. Yes, here it's 4. 4. So is 8.03 minus 0 less than or equal to 4? No, not a triode. So this is the wrong number. So we have to check for the other number. Most probably it will be correct. So VD minus VS, is it less than or equal to 4? Is 0.05 minus 0 less than or equal to 4? Yes, it is. Therefore, triode. This is our correct answer. Okay? Finding VD and ID. Correct? We need to find ID still. So now, ID is equal to what? So this is our correct VD. ID is equal to VD minus 0, or no, it's 5 minus VD over 24.8K. We wrote it here. Okay, so now VD is equal to what? 5 minus 24.8K multiplied by 0.05, and this will result in 0. Actually, we want the ID. What am I doing? It's 5 minus 0.05 divided by 24.8K. This will give us 0.2 milliampere. Okay. Next question. We need to find RD maximum while MOSFET remains in saturation mode. This means we are in edge of saturation. Okay, so we need to find RD. We said that RD, first this is NMOS. Here we have to do Thevenin, correct? Only V Thevenin, VS, VD, ID, and ID. Let's find VG first. This is VG. VG is equal to 10 multiplied by 10 mega over 10 mega plus 10 mega. This will give us 5 volt. Okay, we're done with VG. We need to find RD maximum, correct? RD maximum is equal to 10 minus VD over RD. 10 minus VD over ID, because RD is the subject of the formula. Now, no given numbers, no nothing. Now we have VT. VT is given, VTN it's 1 volt, and Kn prime W over L is 1 milli A over V squared. Okay, so we need to find VD and ID. VD we can calculate it through the ID. It will be Ha UN COX W over L VOV squared. Okay, ID is unknown, half 1 milli multiplied by VOV, which is unknown, so let's compute it. VG minus VS minus VT. What's VG? VG is 5, VS is unknown, VT is 1, so it will be 4 minus VS. 4 minus VS. Okay, so here we have one equation and two unknowns. We need an equation that relates ID with VS. ID is equal to VS minus 0 over 6K. So here we're going to say that VS is equal to 6K ID. ID is equal to half milli 4 minus 6K ID, entire thing squared. So this will result in half milli 16 minus 48K ID plus 36 mega ID squared. Okay, then simplifying, this will become 8 milli minus 24 ID plus 18 kilo ID squared. This will become 18K ID squared minus 25 ID plus 8 milli equal to 0. That's why it became minus 25, because there's a 1 ID here. Okay, using the quadratic equation through the calculator, this will result in 0.89 milli and 0.5 milliampere. We need to pick one number. So what are we going to do? We're going to check which is the correct number. Now, here we are in edge of saturation, correct? In edge of saturation, we know that VDS is equal to VOV. VDS is equal to VOV. VD minus VS is equal to VG minus VS minus VT. VS and VS, they cancel each other out. VD is equal to, VD is unknown. VD is unknown, and Vg is 5 minus 1. So it will be Vd equal to 4. Okay? Actually here we could have computed Vd. It's equal to 4. VOV, because of edge of saturation, we can say VDS equal to VOV, VD minus VS equal to VG minus VS minus VT, correct? S and S, they cancel each other out, so it will be 5 minus 1, 4 volt. So here it's 10 minus 4 divided by ID. We need to compute only ID. Let's go back here. So VD is 4 equal to 5 minus 1, so 4 equal to 4. We haven't reached to any point. Same thing will go here. VD minus VS, VG minus VS minus VT. S and S, they cancel each other out. So here 4 equal to 5 minus 1, 4 equal to 4. So both of them are edge of saturation. So if they are in edge of saturation, then it's not greater than nor it's less than, because they are equal. This means that the only check left is the cutoff. What is the check for cutoff? Check for cutoff in NMOS is VGS less than VT. VGS less than So is Vg minus Vs less than Vt? In order to solve this, we need Vs. How can we find Vs? Through ID, because ID is equal to Vs minus 0 over 6k, Ohm's law. Vs minus 0 over 6k. So Vs is equal to 6k multiplied by 0.89 milli. Okay, this will result in 5.34 volt. Is 5 minus 5.34 less than 1? Is minus 0.34 less than 1? Yes, it is, therefore cut off. Hence, this is not our number. Doing the same thing here. Vg minus Vs less than Vt. ID is equal to Vs minus 0 over 6k. Vs is 6k multiplied by 0.5 milli, 3 volt. Okay, Vg is 5 minus 3 less than 1 is 2 less than 1. Yes, no, it's not cut off. No, it's not cut off. Therefore, this is our number. So, what's RD maximum? What's RD maximum? It's 10 minus VD over ID. We said that ID is 0.5 milli. So here you will get 6 divided by half is 12 kilo ohm. Okay? This is the answer. Next question. We need to find the R's, the 4 R's. We are given VD, we are given VS, and we are given VG. No, we're not given VG, okay? And we're given ID also. Okay, so the first thing that you have to do is assume saturation. Then we will say that ID is equal to half Kn prime W over L VOV squared. ID is 0.32 milli. Half Kn prime is 1 milli VOV squared. This will give us VOV equal to 0.837 volt and minus 0.837 volt. Because we are in NMOS, we will pick the positive number. We will neglect the negative number. After finding VOV, let's open it. VG minus VS minus VT. Okay, 0.837 equal to VG, which is unknown. VS is given 1.6, and VT is also given, which is 1. So VG is equal to 3.44 volt. Good. Now, ID is equal to 5 minus VD over RD. RD is equal to 5 minus VD. What is VD? It's 3.4 over ID, which is 0.32 milli. This will give us 5 kilo ohm. Doing the same thing for RS. RS is equal to VS, which is 1.6 divided by 0.32 milli, will give us 5 kilo ohm. Okay? Now we need to find RG1 and RG2. VG was found to be 3.44. And we already have I2. I2 is in series on both of them. It's the same on both of them. So RG2, let's do Ohm's law. It's 3.44 minus 0 over RG2. This is 1 micro. So RG2 is 1.6 mega. Sorry, it's 3.4. The other number is 3.4 mega. Doing the same thing for RG1. I2 is 5 minus 3.44 over RG1. RG1 is equal to 1.6 mega ohm. Okay, we're done for this question. Now for the circuit, find the value for this circuit. Find the value of R. That results in VD 0.8 volt. The MOSFET has VT equal to mu and COX and W over L. Let's forget about. It's a drawing lesson. Okay. Now, here if you notice, we have a connection between VG and pardon me, VG and VD. Okay. Always, if there's a connection between VG and VD, then we are in saturation. There's no need to check. We are always in saturation. So let me write it as a note. When there is a connection between VD and VG, then we are in we are in saturation. Do you want us to prove it? Now here in NMOS, for saturation, VDS has to be greater than or equal to VOV. VDS has to be greater than or equal to VOV. Check. VDS has to be greater than or equal to VOV, which is equal to VD minus VS, VG minus VS minus VT. S and S, they cancel each other out. Okay. VD and VG, they are equal, so they cancel each other out. What we're left here with is 0. Is 0 greater than or equal to minus VT? Now VT will always be positive because of NMOS. And here minus, it will be negative. Hence 0 is always bigger than negative. Therefore, it's always saturation. Same thing will apply for PMOS. Okay, because here it's less than. Now, how do we solve this question? We need to find R. I told you whenever you see the requirement R, you will do Ohm's law. So it will be 1.8 minus VD over ID. Okay? 1.8 minus VD. What's VD? VD is 0.8 given in the question. And ID is unknown, but we can compute it. through half mu n COX W over L VOV squared. Half mu n COX is 0.4 milli. W over L is 0.72 over 0.18. VOV squared, which we can compute on the side, Vg minus Vs minus Vt. Vg is Vd, which is 0.8, Vs is 0, and T is 1, correct? Vt is 0.5, it's not 1. 0.5 here. So this will result in 0.3 volt. 0.3 volt squared will give us 72 microampere. 72 microampere. Solving this will give us 13.9 kilo ohm. Okay. Next, the figure shows the circuit obtained by augmenting the circuit of figure 5.9 considered an exercise whatever with a transistor Q2 identical to Q1. So Q2 is identical to Q1. What does this mean? This means that the numbers, actually it all depends on the previous. Anyhow, I will tell you the information. It says Q1 is identical to Q2. It also says that Q2 is operating at edge of saturation. Okay? And the numbers are Vd equal to 0.8 volt, Vtn 0.5 volt, Kn prime, W over L 1 milliampere over V squared. We're just taking the numbers from the previous question here. But regardless, just focus on this question. It's independent of the previous question. So here, Q1 is identical to Q2. What does this mean? It means that these two numbers are the same for both transistors. Both MOSFETs. And Q2 is operating at edge of saturation. Okay, what about Q1? Which region is it operating in? Look at this connection between VG1 and VD1. Hence, it's what? Saturation. Okay? This is VD2, this is VS2, this is VG2, VG1, VD1, and VS1. This is ID1, and this is ID2. This is 1.8 also. So, we need to find R and R2. Let's start with Q1. Q1, we said you are in saturation, and R is equal to 1.8 minus VD1, which is 0.8. It's given here. 0.8 divided by ID. And ID is equal to, it's unknown, we have to compute it. So we can compute it from here. Half mu n COX W over L VOV squared. Half mu n COX is 1 milli. VOV is equal to VG1 minus VS1 minus VT1. VG1 is VD1, which is 0.8. VS1 is 0. VT1 is 0.5. Hence it's 0.3 volt. 0.3 squared will result in 72 microampere. Sorry, it's 45 micro. 45 microampere. Okay? 45 microampere. Plugging this number here will give us 22.2 kilo ohm. Okay? After doing Q1, let's do Q2. Q2 edge of duration. Okay, so what's R here? R is 1.8 minus VD2 over ID2. 1.8 minus VD2 over ID2. We can find let's start from VD2. We know that VDS is equal to VOV. VD minus VS is equal to VOV. VOV is equal to VG minus VS minus VD. 2. VG2 is equal to VG1 and it's equal to VD1 and it's equal to 0.8. So 0.8 minus 0 minus 0.5, 0.3 volt. 0.3 VD2 minus 0 equal to 0.3, hence it's equal to 0.3 volt. Okay, we're done with VD2. We need now ID2 only. ID2 is equal to half mu NCOX W over L VOV squared. Half mu NCOX is what? 1 milli. VOV is 0.3 squared. This will give us 45 micro ampere, which is equal to 33.3 kilo ohm. Okay, so now we have analyzed MOSFETs with only DC sources. Now we're going to analyze the amplifiers as we did with chapter 4. Now for amplifiers we have AC and DC circuits. This is AC, this is DC, and this is also DC. So there are several steps that we need to follow in order to solve such questions. The first step is to do DC analysis, which means to kill AC and keep DC. Kill AC and keep DC. So this will be the resulting circuit after we have killed the AC. Next we need to calculate VO. VO is always with VD. VD is always the VO. Okay, and you are always in saturation, therefore there's no need to check and to assume. So this is the equation of ID. The third step is to compute only GM. GM has two equations. It's either Kn VOV or 2ID over VOV. It depends on what you have. Okay, I recommend this one because most students they confuse the Kn with Kn prime. They miss multiplying by W over L, so it becomes Kn. Fourth step is to do the AC analysis, killing DC, keeping AC. Fifth step is to replace the MOSFET with pi model or T model. Sixth and the final step is the requirements. Most probably it will be the gain. Now, this is the pi model and this is the T model. Okay, let's start. Now, use pi model. VT is 0.4, Kn prime is 0.4 milli, W over L is given, VDD is given, which is this. Okay, RD is given, this is RD. VGS is given, which is 0.6, and find VO over VI. Let's begin. Step number 1, kill AC, keep DC. This and the circuit will be like this. Okay, next we need to find V naught. We are always in saturation, hence ID is equal to half NMOS, hence mu n COX W over L VOV squared. ID is unknown, half mu n is mu n COX is this, W over L is 10, VOV squared, you need to compute it, VG minus VS minus VT, VG is 0.6, minus Vs is 0, T is 0.4, hence 0.2 volt. ID is equal to 0.08 milliampere. Okay, after finding ID we can compute VO through Ohm's law. It will be 1.8 minus 17.5k. I did it in one step, but you can do it first Ohm's law and then rearranging. 0.4 volt, and we have found V naught. Next, step number 3, calculate GM. Now we said GM has two equations. It's Kn VOV and 2ID. Just this time I will solve it using the two equations. I just want to prove to you it will give you the same answer. Now what's Kn? Kn is 0.4 milli multiplied by 10. This is both of them is Kn. So Kn is 0.4 milli, yes, multiplied by 10. Then we need to multiply by VOV, which is 0.2. This will give us 0.8 milliampere over volt. Same thing here. 2ID. ID is what? 0.08 milli. And VOV is 0.2. This will result in 0.8 milli A over V. Okay. Step number 4. Kill DC, keep AC. Now we have to remove the DCs and keep the ACs. The circuit will be like this. Next, fifth step is replace transistor or MOSFET with pi model. Sixth step, V naught over VI. Now, pi model, because the question asks for pi model. What's the pi model? Let's copy paste it. Okay, copy, paste. Okay, what's connected on G? G is only a voltage source and its name is VGS. I think it has to be small letters, yes. S is grounded and D is only connected with a resistance and a ground. So here it's 17.5 kilo ohm and this is the output. So how can we compute now V output over V input? We need to start with V output. We will say that V output is minus ID multiplied by 17.5k. ID is equal to GM VGS. VGS is equal to VGS positive minus VGS minus. VGS positive is this, which is VGS minus 0 rounded. So it will be VGS, taking this, plugging it in here, to result in the same formula. Plugging this back in here, this will give us VO divided by V input is minus GM multiplied by 17.5K. GM is 0.8 milli, and this will give us minus 14 volt over volt. Okay, this is the end of this question. Next, we need to use pi model. VDD is 5, VT is 1, RD is 10K, RD, VGS is 2 volt, and we need to find VO over VI. This is the same thing. Kill AC, keep DC. Let's do the second step at once. Calculate VO. The circuit will be like this. $5 volt, 10K, $2 volt. V naught is here. This is ID. We are always in saturation. This is VG. Okay. Now we have to say that ID is equal to half mu n COX W over L VOV squared. Half 20 micro multiplied by 20 multiplied by VOV. VOV is VG minus VS minus VT. VG is 2, VS is 0, and T is 1, so it will be 1 volt. This will result in 0.2 milliampere. After finding ID, let's find VO. ID is equal to 5 minus VO over 10K. So VO is 5 minus 10K multiplied by 0.2 milli, which is equal to 3 volt. Okay. Step number 3 is computing GM. GM is 2ID over VOV, 2 multiplied by 0.2 milli divided by VOV, which is 1. So this is equal to 0.4 milliampere over volt. Fourth step, kill DC, keep AC. And the circuit will be no DC source, resistance which was 10 kilo ohm. There will be an AC source, VGS grounded, and VS was grounded. Okay. Fifth step was using pi model. Sixth step is VO over VI. Let's copy the pi model. Okay, copy. Pasting. Now, G is connected to a source, VGS. S is connected to ground, and D is connected to resistance and ground. VO. Now, VO is equal to minus 10K multiplied by ID. Let's write it first, minus ID 10K. ID is equal to GM, VGS. VGS is equal to VGS positive minus VGS minus VGS positive as VGS minus 0, which is equal to VGS. GM VGS, plugging this back in here, will result in minus GM VGS multiplied by 10K. So now VO over VI is equal to minus GM multiplied by 10K, and this will give us minus 4 volt over volt. the last and the final question in this chapter and in this course is the following. We need to find W, which is the width, and VGS, given those numbers. Now you need to think. We are given also ID. Now in ID we have two options, either triode or saturation. So now we have to think, are we in triode or are we in saturation? Should we assume and then solve and then at the end we have to check? Well, if you notice here that we have a GM, where does GM exist? It exists in amplifiers, and amplifiers are always in saturation. So this will give you a hint. We are always in saturation in amplifiers. Okay, and we knew that we are an amplifier because of the existence of the GM. Okay, so now GM is equal to 2ID over VOV, correct? GM is 1 milli, 2ID is 0.5 milli over VOV. So VOV is equal to 1 volt. Opening VOV will result in, or before we open it, maybe we don't need to open it, we need to find VGS, which is equal to VGS minus VT. So VGS is equal to VOV plus VT. So it will be 1 plus 0.7, 1.7 volt. Okay. Now, we found VGS. We need now to find W. W can be found only from the equation of ID. So to be half mu N cos of NMOS COX W over L VOV squared. ID is 0.5 milli, half Kn prime W over L is 50 micro multiplied by unknown over 1 micro multiplied by 1 squared, which is VOV. So if you compute this, W will be 20 micrometer. Okay, so we have concluded this chapter. I hope you have learned from my videos. Thank you very much.